In this video, I'd like to remind you of something that we study often in first semester organic chemistry when we study alkenes and their reactions. I want to show you how to make an ether using a mercury compound and an alkene. Let's jump right in. We can take an alkene and let's make this alkene lopsided. There's more carbons on one side than the other side. And if we go back and remember all of our alkene reactions, there's one that looks like this. It has mercury in it. Mercuric acetate. Mercury with two acetates on it. Mercuric acetate. And if this is run in water, followed by sodium borohydride, you might remember that this makes a Markovnikov alcohol. That means this double bond reacts, so let me draw everything else on here. So two carbons on the carbon on the left, two hydrogens on the carbon on the right, and we add water across this double bond. So there's an H that goes to one side, and an OH, so H2O, add across this double bond to make what's called a Markovnikov alcohol. Markovnikov just means this special group goes on the carbon that has more carbon groups on it. It's more substituted. So we learned that back in first semester organic chemistry when we learned about alkenes. I want to remind you that you don't have to run this reaction in water. If I do the same reaction with mercuric acetate, but instead of water, I add, let's pick an alcohol as my solvent. So it might be methanol, ethanol, whatever, followed by sodium borohydride. I'm going to take my double bond. I'm going to add across it, so I'm going to make this a single bond. On the left carbon, I'll put my two carbons. On the right carbon, I'll put my two hydrogens. And instead of adding water across the double bond, now I'm going to add the alcohol across the double bond. The H goes on one side and the OR group goes on the other. Again, it makes a Markovnikov compound. So the special group, the OR, will go on the more substituted carbon, the more carbons on it, and the hydrogen of the alcohol goes on the other side. So we've added alcohol across the double bond. And I want you to see that my alkene now is a Markovnikov ether. There's a carbon, an oxygen, and a carbon. I made an ether this way. So that's the main idea on how to make Markovnikov ethers using mercuric acetate with alcohol as my solvent, followed by sodium borohydride. Now as a bonus, I'm going to walk through the mechanism because sometimes seeing how it goes together helps you understand it. Now this mechanism I call the triangle mechanism. It's one of several reactions that we call triangle mechanisms in my language. You can watch a video. There's a link, put a link right above here. So you can watch the triangle mechanisms for other reactions if it's helpful. And look at my analogy in that video. But I'm going to assume you've watched it and just talk like you've seen that other video. So, all right, I'm going to jump right in and show you how to do this reaction using that analogy. So the first step is mercuric acetate so there's two acetates on it. Let me write the other one on here. One of those acetates leaves. So right, there's two acetates. One of them leaves to make this positive mercury acetate thing. Now I have my double bond compound, my alkene, and these juicy negative electrons will go attack this very big positive mercury thing. And mercury has so many electrons it donates some of them back. So what you end up with, where my double bond was, I have my two carbons on the left, two hydrogens on the right, and my mercury acetate has a positive charge on it, and it's being held up by both of those carbons at once. I like to think of the mercury as being so big that not one carbon can hold it or the other. It takes both of them to hold it up above its head. Now, in my analogy, this is, so you have to go back and watch another video. This may not make sense. But this is the victim in the analogy. This is a victim that's carrying money. So he's holding a sign above his head that says, hey, I'm holding money. These carbons right here are the bags in that analogy. So he's carrying money, this positive money, more in this pocket on the left side, underneath these bags, and not in this pocket. So my alcohol, with its juicy electrons, attacks from the bottom back side because the big mercury is blocking the top of this molecule. That would make 5 bonds on that carbon. We can't do that unless we can fix it. But we can fix it by moving these 2 electrons up onto the mercury. That makes a carbon on the left with 2 carbons on it. It has this alcohol on it with now just 1 lone pair and a positive oxygen. This carbon's bonded to this carbon with 2 hydrogens on it. And my mercury acetate up here. Anytime you see something like this, you want to clean it up with another molecule of alcohol. So I'll grab that hydrogen. These electrons stay behind. So I have an OR. Now I pull that hydrogen off. And I have 2 lone pairs. This one and those electrons are still on the oxygen to make it neutral. This carbon with its hydrogens and the mercury is still on it. Now the final step is to add that sodium borohydride. That's a source of hydride, hydrogen with a lone pair of electrons and a negative charge. And this isn't exactly the mechanism, but this is the way I think is best to remember it and not get too deep into the weeds. But it just directly replaces that mercury to add this hydrogen from the hydride source. But I want you to remember the triangle reaction. It attacks from the back side on the carbon that is more substituted to end up with the special group that attacked on the carbon with most carbons on it. Maybe that helps you remember that. So this is how to make ethers on a Markovnikov carbon of an alkene using mercuric acetate and an alcohol as my solvent. Hey, subscribe to the channel and watch more of my organic chemistry videos so I can help you be successful